Rapid Spanning Tree Protocol 802.1w by me, Astrid Krasniqi. Rapid Spanning Tree Protocol RSTP 802.1w, open standard protocol, can be seen as an evolution of the 802.1w standard more than a revolution. Evolution because the main improvement is it's fast, speed, so it's a rapid. And the one big disadvantage of the Spanning Tree protocol is that it's low convergent, which is very important in the switch network. Low convergent, we mean that it's very slow. It takes up to 50 seconds to converge with the timers, blocking, forwarding timers, listening, learning, and so on. Rapid Spanning Tree protocol reduces the conversion time after topology has changed occurs in the network. Different roles, well not different, there's few different roles, but the main roles in the Rapid Spanning Tree. Port roles, we have a designated port. A port is designated if it can send the best BPDUs on the segment to which is connected. A forwarding port for every segment. Now that's a root bridge, and the root bridge, of course, every port on the root bridge is designated port because it's the fastest link to its own root bridge. So that all the designated ports are in forwarding mode. Then we have a root port. This is the port that is the closest to the root bridge in terms of the path cost. Now these two switches or bridges, they are like non-root bridges. They connect the fastest port to connect to the root bridge. It's considered a root port. Then we have an alternate port, a best alternate path to the root bridge. So for two bridges underneath, they have another alternate port, which that port is going to be on the blocking mode. It's considered alternate port as if the designated port on the other switch fails, there's another path towards the root bridge. Then we have a backup port, a backup redundant path to a segment where another bridge port already connects. So those two switches, the switch on the right, if it has another path, that's considered a backup port. If the designated port fails, then the backup port will take over. Port states are few similar to Spanning Tree protocol, but there's some new ones. So Spanning Tree protocol 802.1d standard comparing to the Rapid Spanning Tree 802.1w. The first is disabled. On the Rapid Spanning Tree is discarding. It doesn't learn port MAC addresses. Then we have blocking, discarding. Well, let's read the Spanning Tree first. We have all the 5 states: disabled, blocking, listening, learning, then forwarding. There are 4 states in Spanning Tree protocol. Now Rapid Spanning Tree, we have a discarding, 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 then learning and forwarding. So disabled, blocking, and listening, it's all just one word for it, discarding. And then we have a learning where they learn in the MAC addresses, and forwarding where it's fully functional. So discarding, the port that does not accept frames, process any frames, or learns any MAC addresses. But you have to remember that even the port is in discarding mode, it will receive BPDUs and it will process them. Learning, it will learn the MAC addresses, but does not forward any frames. Still, it receives BPDUs as well. Forwarding, well, we have a fully operational port. Edge ports. The edge port concept is already well known to Cisco Spanning Tree users, as it is basically corresponds to the port fast feature. So a switch that connects to the client machine, that port is considered edge port in Rapid Spanning Tree protocol. Unlike port fast, an edge port that receives a BPDUs immediately loses its edge port status and becomes a normal Spanning Tree port. Cisco implementation maintains the port fast keyword be used for the edge port configuration, thus making the transition to RSTP simpler. So we still use port fast, but we know the port fast is a Cisco proprietary protocol. So edge port, but just the keyword is still the same. proposal and agreement sequence. When a port has been selected by a spanning tree algorithm to become a designated port, in 802.1d still waits for twice, 4 delay seconds 2 times 15 before transmitting it to the forwarding states. Remember the forward delay, they were listening and learning. Well, first learning, then listening. The proposal agreement mechanism is very fast as it does not rely on any timers. This wave of a handshake propagates quickly towards the edge of the network. So two switches, they have a proposal, and the other switch gives an agreement to who will be the root bridge. Okay, we will do a configuration demo. We'll do between two switches and two PCs, and we'll see the difference between a spanning tree and a rapid spanning tree. Right, now we will do a configuration between two switches and two PCs, where the one switch is going to ping the other PC, and we'll see the difference between a spanning tree and a rapid spanning tree. Here I'm going to bring two switches to our network. We'll call this switch A, or SWA, and this one will be switch B, so SWB. Okay, bring two PCs. We say this one is going to be PCA, and another PC, you guessed it, PCB. Okay, I'm going to connect these two together. Right, PC is going to go to port FA01. So PCA, fast Ethernet, to switch port FA01. I'm going to write that down just so clarity, FA01. Right, now connection between two switches, I'm going to double connect it. Do you remember what cable we need to connect two switches? Well, I hope you guessed it, crossover cable. So this one I'm going to connect FA023 with FA023, and I double connected again with FA024 with FA024. The switches that I'm using is 2950, I think is the first one, yes. And then another connection here between switch B and PCB. So it's straight through cable, FA01 here with a fast Ethernet on the PC. Okay, just gonna rock here, FA01. These two connection is FA023. Copy that, and again right here, FA023. And this connection here, it's FA024 with FA024. Okay, alright, now I'm gonna just take these labels off because they just on the way. So what the preferences, then show device name label, untick that so we don't see labels. Oh, what did I do? No, hold on. Show the label name, but device model, take it off, we don't need that. So here we go, we have a switch A and a switch B, PCA and PCB. Let me get rid of that one there. You can do the configuration of the name on here as well, where it says display name. Just get rid of that one. Okay, so this PC here is going to have, if I look again, what did I do in this configuration demo? Yeah, 192.168.110, this PC A here, and PCB is going to be 192.168.1.20. So the IP address here that I'm going to give to this PC, 192.168.10.1. Let's go and have a look again. So 1.10. Okay. 10 4/24. Need to remember that. And this PC is gonna have 20. Okay, so 20. There we go. This kind of configuration. So we go there to configure PCA. Say desktop IP configuration, and it's going to be 192.168.1.10, and default subnet mask is correct. And PCB is going to be again 192.168.1.20, and default subnet mask. Okay, so from this window, we can tell right away who's the root bridge and which port is blocking, but you wouldn't be able to if you just look at the real devices. So if we go to this switch B, and let's put this one to a different VLAN. So we're gonna put them on the VLAN 10. VLAN 10 for each one. So this PC is gonna be on VLAN 10, or this port I should say, and this port on the switch is gonna be on VLAN 10 as well. Okay, so these two, they need to be truncated, the switch A and switch B. So I can go to switch A, go to command line interface, and just try and fit it in our recording. Okay, here, that's fine. Enable, configure terminal, host name SWA, this one. So two interfaces, FA023 and 24, they need to be truncated, so we access range. So interface range FA023 up to 24, switch port mode trunk. Okay, and we need to enable the VTP if we want to synchronize our VLAN. So VTP domain CCNA. Okay, so we've done that, and we have to create one VLAN. So VLAN 10, name PCA, and PCB VLAN, and show VLAN brief. You see that our VLAN is there. VLAN 10. Show interface trunk. Oh yeah, you see 23 and 24 are truncated. Fine. We should go to switch B and have a look at that. In here, enable, configure terminal, hostname SWB, and do show VLAN brief. Yep, VLAN 10, we can see the VLAN 10 has arrived. I went through the configuration of the trunking interface quickly and the BTP configuration quickly, but you should watch those videos. This video is about rapid spanning tree. So if I do show, yeah, we have do show VLAN 10, but we don't see port FA01 belongs to VLAN 1. So we need to move that port to VLAN 10. To do that, we access the port, interface FA01, switch port, mode, access, switch port, access VLAN 10. So that command makes it an access port, and then we access in it VLAN 10 with that port. Access port can access only one VLAN. So do show VLAN brief. You can see the FA01 has just moved now, it's on VLAN 10. And we do the switch A. So if I go to switch A, Okay, so now I'm in switch A. So if I do show VLAN brief here, VLAN 1, the port 1 is still missing here, so we need to do that here. Config D, interface, FA01, switch port, mode access, switch port, access VLAN 10, and WR for saving the configuration. So if I go to packet tracer again, access PCA, open the command prompt, and PCA should ping PCB, so we want to ping that address. So if I do ping 192.168.1.20, I should get replies. So let's just wait. First ping, request timeout. That you remember, it's ARP, so I was expecting the first ping to drop. So if I repeat the command, then none of the pings will drop. Okay, excellent. Now if I go to switch A again and do a show spanning tree VLAN 10, I can see that this is not the root bridge, since it doesn't say that is a root bridge, and the root port is chosen FA023. It came down to the lowest number, the port number, and 24 is alternating and it's blocking. So if I go to switch B and do show spanning tree VLAN 10, see the switch B, it is actually the root bridge, and I haven't changed the priority, it has picked up from the MAC address. So 0049A, can we see there 0049A 9699? Yeah. So this is the information here is about switch A. So the switch A address, MAC address, when you compare to switch B MAC address is better, because on this third bit is 0 or hex number, and here is 6, so we know the 0 is lower than 6, so that's why he won the election. So he's the switch B is the spanning tree root bridge. So we can see that we're running a spanning tree protocol here. So any if it goes down in any problem, the convergent will take up to 50 seconds. So again, I'm going to go to PCA and ping PCB, and we're gonna run like a continuous ping. So we're just gonna do it, leave it there, and then we'll see what happens. So ping -t 192.168.1.20. So that's a continuous ping, and then we're gonna go to let's go to that so we can see both, and switch A. So on switch A, I'm gonna minimize it a little bit. Okay, so show spanning tree VLAN 10. So this port is actually forwarding, that's a root port, so our pings are going there. So if we shut down this port, we'll see how many packets are going to be dropping from this PC while it's pinging the PCB. So access that port, config T, interface FA023, shut down. Okay, shut down the port. Do show spanning tree VLAN 10. There, the 24 is listening. We drop in some pings there. Now it's learning for 24. We don't see 23 because we just shut it down. Again, still learning. And now the pings has come back. So you can see there, now it's forwarding. That's a root port. So it took up to 5 pings we missed. So if we look, this is the port that we just shut down, and this port has came back up as forwarding. So okay, I'm gonna leave the ping going there, so I'm gonna bring that port up. So no shut down. Do show span VLAN 10. So we can see now that port 24 is going back to blocking, and port 23 is listening. Then it will be learning, and then forwarding. But see, the problem is that even if something goes bad, you're going to lose a packet. But even if the port comes back up, which is good, somebody has fixed it or whatever, we're still losing packets. We're still dropping the connections and so on. So now we can see that it's forwarding. Okay, so I'm gonna stop this ping here, and now we're gonna change the mode to rapid spanning tree. We have to do that on the both switches. So spanning tree, mode, command. Now we have 2 modes in the packet tracer. We have a rapid spanning tree and per VLAN spanning tree. Well, we're gonna choose rapid. Rapid spanning tree per VLAN spanning tree. So we go to switch B. Over here, switch B here. Okay, so we have to do it here as well. So spanning tree, VLAN, mode, rapid. Okay, so end. Show spanning tree VLAN 10. Still, even though now it says a rapid spanning tree, it's still a root bridge. Timers are exactly the same. How it's calculated, the priority and system ID extension, it's the same. So that's why evolution, yeah, you remember from the first slide. So if I go to switch A and the command prompt, so if I do a do here, I'm writing do because I'm not in the privilege mode. If I want to do it without actually that do, I have to go to the privilege mode and say show spanning tree VLAN 10, and here we have for port FA023, it's in forwarding mode, and 24 is in blocking mode, and this side is a rapid spanning tree as well. So great. So let's start that ping again. Continuous ping from PCA to PCB. Okay, and this time we're gonna block that port, shut down that port, and see how many pings are we gonna lose. So config T and interface FA23, shut down, enter. Right, shut down the port. I don't see any problems there. Do show span VLAN 10. Right. So you don't see any pings losing here. Everything is worked fine didn't even notice that I shut down the port. I really thought that maybe it didn't work or something. But these pings are still going. Yeah. Yeah, you can see that one is going up, so the pings are going. So we don't even notice I just shut down the port. Right away this went back to forwarding, or took over. Okay, so if I do a no shutdown, I'll bring the port back up. No shut down. There we go. No shutdown. Okay, so now this time we're gonna lose any pings. Yeah, we're gonna lose 1 ping. That's why I expected to lose 1 of the pings. But hey, it's much better than a common spanning tree protocol. Okay, this was Astrid Krasniqi helping you explain a rapid spanning tree protocol. Thank you very much for watching, and see you in the future videos. Bye.